Good afternoon, everybody. I know this was the last session of the day, so let's just jump right into it and then we can break for lunch or whatever. And thank you for showing up. Handling millions of requests a day. So the number which was there, 4 million, was actually what our IDP is serving right now to many customers. So the cloud IDP that we have. And scalability for any SaaS platform that is there out there is very critical because we all want to grow and be able to handle, a multiple requests for multiple users. So before we begin, a little bit about myself. I think most of you here probably already know, but for the people who don't know me, I'm expert. I have been, working in identity and access management and with miniOrange for the past 9 years. I'm a scripting aficionado. What that means is I spend 90 minutes writing a script, which will save me a minute from my 5 minutes task on a daily basis. And a general curious cat. The question for you is, let's start with why do we need to scale? It's important to understand why do we need to scale before getting into the scaling, like what it takes to scale an application. Straightforward, first point, obviously we want to be able to handle increased workload. That means the traffic which is coming from multiple requests. General availability of the service. You want to make sure the app that you have now hosted on the cloud is available for all users. You want to make sure it's reliably running, which means it's not enough to just be available 24/7. But if the performance itself is, sluggish, then, you click the submit button and it's 10 minutes and it's still loading, then that's not a good experience. And obviously global expansion. So with that, what is scalability? If you do a quick Google search or do ChatGPT, you'll get something like cloud scalability in cloud computing refers to increasing or decreasing the resources as needed based on your workload or changing demand. Very straightforward. If you go a little deeper or in that definition itself, they'll talk about, the two types of scaling, which is there. One is vertical scaling and one is horizontal scaling. So, and that's it. For the definition, that's where they end. So for people who don't know, vertical scaling is when you add CPU, RAM, or, additional resources to your server, to the existing server that you have. Horizontal scaling is adding multiple servers of probably the same size, same CPU, same RAM, or it can scale based on what you have. So that's it. So is that all there is to scaling an app? Just add servers and you're good. Is that all there is? Is it that simple that, you write any code, put it on the cloud, and then add more servers as the traffic increases? What about the cost aspect of it? You're adding more servers, right? So what about the cost aspect of it? And does adding more servers always solve the issue, or does it create more complexities? So that's what we're going to, look into today. We're going to have a bit of a discussion. This might be a little different from what you might be expecting. We'll go step by step in terms of how you should approach, your application and any scaling needs that you might have. Most of the stuff which you find on the internet is fragmented and has less context. So today we'll try to address some of the issues and the solutions which are there out there. Try to look at it from more of a holistic approach and talk about some hidden complexities that usually are not talked about, while keeping, all this from the experience that we have had with scaling the IDP application on the cloud. So let's just jump right in. So let's go back to that horizontal and vertical scaling that was there earlier we were talking about. If you do a little bit of Google search, they'll give you two. One upside is obviously it's a very quick fix. You have a high traffic demand right now. What do? You just add servers and it will give you maybe immediate relief. The drawback to that, obviously we discussed a little bit, is the cost goes up because you're adding more servers. But unfortunately, it's a temporary relief and can lead to downtime if you're doing vertical scaling, because it's the same server where your application is running. So if you add more CPU or RAM, or if you have ever done it on your laptops, you know that you have to, shut down your laptop, put in the new CPU or put in the new RAM, and then restart the laptop. Same thing happens with the server. So if you're doing vertical scaling, there might be some downtime if you're doing that way on the same server. So one of the things that is not being talked about when we talk about horizontal and vertical scaling, which server to scale. Let's say you have an application, and all SaaS applications have at least a minimum of two things. One is a database server, and one is an application server where your code is running. So which one do you scale? So that is something which is not talked about. Do you scale the database server, or do you scale the application server, or do you scale both? Do you add more servers? So that's something we'll talk about today. Horizontal scaling is great. You add more servers horizontally, but then the question comes, how do you distribute the load or the traffic amongst those, servers? Then are there any changes required on the application side to support horizontal scaling? Yeah, whatever code you wrote, it'll work out of the box and nothing has to be taken care of. You just keep adding more servers. How do you monitor your servers in horizontal scaling? If you have multiple servers, let's say an error occurs, how do you figure out which server was the error at, and then go in and do debugging? And also, how do you even add more servers? Is it just, manually add more servers? Then the question becomes, when do you add more servers? Is it based on some sort of an alerting system? Then the question becomes, how do you set up that alerting system? Do you do it automated? If you do it automated, then how do you do it automated? So those are some of the questions. Those are lots of questions. So let's take it step by step. What to scale? The first question, right? So you have an application server and a database server. There can be other components in your application, but I'm just going to stick to at least these two, but because every SaaS app has at least these two servers. So let's try to answer this question. So what do you look at to figure out which of these two do you scale? The keyword is bottleneck. You need to figure out where the bottleneck is. Your database is also running on a CPU and RAM and can be a bottleneck. You need to ask yourself if your application is process heavy or is it read-write heavy. What does that mean? Is your application spending more time processing a request that comes from a user, or is it spending more time reading and writing from the database? That makes sense, right? So if your application is spending more time reading and writing from the database, your database is the bottleneck or can be the bottleneck. Just adding more application server in that case will not solve your problem. You need to look at your database server. Okay. So how do you go about it? Well, you do something called profiling. Profile your applications and figure out where the bottlenecks are. It will definitely guarantee you better results than just, going to something like Microservice or, adding more servers. So how do you go about it? We'll go by step, looking at your database first. So my recommendation is use an application monitoring tool, or APM is how we call it, which will give you more insights on which queries are being run or which endpoints are being hit, and what is the load, what is the average response time, which will give you better idea in terms of where your focus should be. So with an APM, you can look at all the queries, all the SQL statements that are being run, and which one is the one which is the slowest. And then what you can do is you can use something called explain analyze. That's a tool, I think, which comes in every single database, which will, I think there's an example below. You can run any query and add explain analyze in front of it, which will give you an idea in terms of how much time that query is taking, what it is doing, how many rows it had to scan, did it use any indexes, and so on and so forth. So start with an APM, look at which queries are the slowest, do explain, analyze to figure out why they are slow, and if you need to do something more on it. So once you have figured out what queries are those, then you look at something called denormalization and indexing. So before denormalization, what does normalization mean? Normalization is basically dividing a big table, if you have any, and into smaller tables. Denormalization is the opposite of that. Then the question is, why do I denormalize? What benefits does it give me? If a table is being divided, obviously there are less data there, right? So it's beneficial. Why do I denormalize? Well, it depends if how many joins you have. Join is a heavy operation. You need to figure out if your join is efficient, is using the right indexes, or is it working too much. In which case you can have some redundant columns and simplify the query and and then merge the data on your application layer. It will help you more than actually dividing and doing normalization and dividing your table into smaller tables. So last point is indexing. Indexing is super important. Always look at your queries. Any queries with a where clause should have indexing in there. What it does is it creates a lookup table, and this lookup table helps you or helps the database reach or respond to queries faster. It's like an indexing caching of sorts, which it does based on the index values that you have said that, okay, this column needs to be indexed or these two columns need to be indexed. So that's where you should start from, because your database, many of us think it's the application, but it's most likely your database which is causing the issue. Some few other tips and tricks. This is mostly on how you write your queries. So when you're writing your queries, I'll suggest align your where clause based on indexes. Otherwise, what it does is it will do a full scan of your table. What does that mean? So when you do select star from and you add a where clause, if your where clause is not using an index, it will go through each row in your database, in your table. And when it's doing a full scan, that's a bottleneck, because if it's indexed, it will give you answer like that. So that's something which you can look at. Another thing which probably a few of you might not know, which is using this like query. We tend to add percentage at the beginning and at the end of the keyword that you're searching for. What I'll recommend is, what I have figured out is, when you do that, it does not use, database does not use the indexing. Use the percentage at the end of your string. It will still use your indexes and will give you better performance. Avoid using percentage, string, percentage. Another thing you can do is avoid or and in clauses or in queries. It's better to use union or between. Another thing you can do is the order by clause which you have, align it with your where clause. It will give you better performance in terms of your queries. All right. Some few other tips. Union all is better than union, or is faster than union, because it does not eliminate duplicates or spend time eliminating duplicates. Another thing is you can use your when you're creating your indexes, look at your queries and look at your where clause and create indexes for all of them. That's my recommendation. And then another thing you can do is, if you have to do a join query, put the larger table first. But in case of MySQL, it's a little opposite. You need to put the smaller tables first. There's an order in which the databases tend to run your queries when you're using join. So this will also help in your query performance. Let's jump right into connection pooling. I think some of you might already know this, but I'll still touch upon it. This is an optimization which you can do around database connection. So how does a database connection happen? So it happens, you first open a connection, the client opens a connection to the database. It creates a socket. It keeps that socket open, reads and writes data using that socket which it opened, and then closes the connection and then closes the socket. That's a normal life cycle of any query that is being run in a database. So any IO operation that you do, a general thumb rule, any IO operation that needs to be done is going to be process heavy, which means any socket which is being opened will create bottlenecks in your application. So usually what an alternate solution is, at the start of your application, create multiple connections and pool them. What does that mean is, let's say I create all these 100 sockets and I keep them active when my application is going up with my database, and just reuse those sockets which we created instead of having to create new sockets. So we can avoid some time or the processing power of the database and as well as your application to create those connection between your database and your application each time it has to run a query. And having a pool of connection helps you also. There's something called multiplexer, which means the same connection can be used to run multiple database queries. So always use connection pooling, no matter which language you're writing your code in. It's always beneficial because it helps you avoid any IO operations that you need to do. So these are some popular pooling libraries that you can use. I'll suggest, if you're using a Java application, use Hikari. We moved from C3P0 to Hikari because it provided better benefits and in general was more efficient than C3P0. There's some one for Python and Node. So each library does have some connection pooling. Each language has a connection pooling library. Always recommend to use that. Another general thumb rule is your databases, you cannot create unlimited number of connections with it. There's a set number of connections that you can create with your database, and it depends it varies from database to database, but it depends mostly on your RAM that the database server is running on. And here's a general thumb rule in terms of how to figure out the maximum number of connections that the database can have. And by default, the database server that you deploy will have a set number of connections. So it's always a good idea to check and increase the number of connections based on this general formula. All right, what next? Now that you have looked at your queries, you used APM, you looked at your slow queries, you did indexing, you did denormalization, but now you're still hitting a bottleneck. Okay, so what do you do? Well, I think now is a good time to then look at adding more servers or scaling your database. So you can start with increasing the CPU or RAM of the existing database. But one question which is there, how do you do that without having any downtime, right? Because if you go to increase the CPU and RAM of the existing database which is running, and you want to ensure that 24/7 availability that you're claiming for your application, how do you vertically scale a database server? So one thing you can do is something called create a replicated server, which will keep anything that happens on your master database, it gets replicated to your child or sub whatever you call it database, and after that you promote that child as the master and just delete or archive your previous database. So simple enough. Create a read replica with your increased CPU or RAM. Let it replicate whatever data was there on the master, and then after that promote that server, and your application should be able to connect to that new database automatically, and it will avoid a little bit of downtime compared to if you were just increasing the CPU or RAM of the existing database. Okay, now let's look at, let's say you did all that. You can also look at something called read-write replicas and CQRS, which is command query responsibility segregation. What does that mean exactly? So what you just need to figure out is, let's say we looked at first where the bottleneck is. Even in database, you can look at, is my read operation, is my application read heavy or is it write heavy? Which means, am I reading more from the database or am I writing more to the database? And then accordingly figure out, do you need to scale your database for read operations, or do you need to scale your database for write operations? And what you can do is, generally what we have done is, we created read replicas, and then we horizontally scale our read replicas. All the read replicas will keep replicating the data from the master database. And you can scale your read replicas so that any read operation that is happening, any high traffic that comes in, and if your application is read heavy, it gets scaled or distributed amongst your read replicas. So one thing that doesn't get talked about in this, when you're horizontally scaling your read replicas, is the types of replication which happens. So this is something which you can look at and then figure out if it fits with your application needs. So there's asynchronous replication. What it does is, like, your primary database node, which is the main master node, it needs confirmation, or it sends the replicated data to your read replicas, and it doesn't wait for some sort of confirmation. It just sends the replica and assumes that the replication happened. The downside to that is your read replica might fail in being able to replicate that. So you need to take that into account. Another one is synchronous. Simple enough, opposite of asynchronous, which means the master database will wait for confirmation from all of the read replicas that the replication has taken place. And then after that, commit to your application that, okay, the SQL query has run successfully. It guarantees, your data consistency across your read replicas and the master database. Another one is semi-sync replication, which means it's somewhere in between. So the master database doesn't wait for an acknowledgement. It just waits for acknowledgement that the read replica has received the request for replication. So it doesn't wait for read replica to actually commit the data and then send a confirmation. It waits till okay, I have received the request, and that's it. So that's somewhere in between. So if your application is the application that you're writing, you need to ensure that there is no delay in committing and reading of data. I'll suggest go for synchronous. But if you feel that, okay, there can be a bit of delay and it's fine, go for asynchronous replication, right? So it will give you increased performance, but then it might not, it might be a bit slow in terms of, after committing the data, are you able to read the data? Now that we looked at read replication, let's say your application is write heavy. So what do? This is where things get a little complicated. You can have multiple master nodes, and both of them can write the application, perform write operations. Usually this is done if you are having a single application globally, and you want to avoid some latency between, let's say your application is running, one set of application is running in India, and another same application is running in the US. But then you want to have that consistency between the database. So you can replicate the data between your master 1 and master 2. In this example, there's just 2 masters, but you can add more masters, but it just increases the complexity of it. And then you can have individual read replicas for each master node. A few things you need to take into this account when having 2 different master nodes is it's going to be slow. So what that means is you're writing to both the master nodes, so they'll send each other replication data. So eventually there will be consistency, but then it's going to be a lot slower compared to if you just had read-write one master node and multiple read replica nodes. So a critical thing that you need to take care of when you're having multiple master nodes is conflict resolution. Let's say there is a commit on this master node and there's also same commit on the other master node. How do you ensure, you're not writing to the database twice? So that is something you have to do on your application layer, and little bit, you have to take care of this little bit on your application side. We'll move on to something called partitioning and sharding. This is also something which you can do or will eventually have to do to improve the performance of your database. So there are two types of partitioning. Usually it involves, both partitioning involves creating smaller tables from your main tables. So let's say if you have 1 billion records in one table, the database, and you want to, like a reporting, or auditing, and you have billions of rows and you want to get some data out of that table, would obviously result, even if you have done indexing, it's going to be slow. So one thing which you can do is divide that table into multiple tables and then, query the specific table where you feel the data is, either via logical segregation. And it will help you improve your results of your, how fast the database is responding. Otherwise, it will scan through 1 billion rows, which is obviously going to take some time. So first is vertical partitioning and then horizontal partitioning. So what is vertical partitioning? So if your table has multiple columns and you divide that table into a smaller table with, let's say, smaller number of columns, that means you slice the database or the table from between, and you are segregating the columns into two different tables. That's called vertical partitioning. That's also what normalization also means. And another one is horizontal partitioning, which is more of your cutting the database or the table in half vertically. That means is, if you look at this example, there were a reports table and then you divided it based on months. So January, February, March, right? So both help with, if you have a large table with a lot of data, you can partition that data so that, the database queries are quicker. One quick note, what about sharding is, it is basically horizontal partitioning, but you keep those tables in different databases, which means if you have multiple read replicas, one would go in one database and another table will go in another database. So that's sharding. Usually it's done where, when your application is huge and it has billions and billions of records, that is something which you can look at. But sharding involves a lot more, it adds a little bit of more complexity, because you have to figure out which database to connect to get the relevant data. So if I want February's data, I need to know that the data was in, database 2 and not in database 1. So that is something which you need to handle on the application side. So what next? Obviously now next we you start looking at caching, which is a layer on top of your database. Database queries are always going to be slow, but if you have frequently accessed data, you can keep it in memory. Anything fetching something from in memory is always going to be faster compared to fetching it from a persistence, database. So I think everybody understands caching, which is faster access, improving performance. There's less load on your database itself. And let's say your database does go down at any point, then for a brief few minutes, or depending on how you have set it up, your cache can basically, still make sure your application is available because it is caching your data. So some few tips and tricks around caching. Always cache the data which is frequently accessed and is not changing frequently, which means is if your application is, or the data is being rewritten a lot of times, and if you cache that data, it's not going to show you benefits. Only the data which is probably written once and does not change for a period of time, you can cache that data. It will give you better benefits compared to, because your application will keep invalidating the cache and writing to the cache, which is basically same as writing and reading from the database. Try and avoid caching large objects because it reduces performance. It's important to choose the right caching strategy and the TTL, time to live, which means how long the data should be in your cache. So those two things you need to take care of while you're setting up any sort of cache. Caching strategy, there are mostly three. One is lazy loading, which means you load the data into the cache on demand. It's not when the application accesses the database and you get the data back, and then you are caching rather than on the application load, you're caching the entire database, right? So that's one thing you can look at. When do you do lazy loading into your cache, or when do you cache the entire table itself in your cache? Then the other two are write through and write back. What that means is, should you cache after it commits to the database, or should you cache first and then wait for the database to actually commit the data? Both have their pros and cons, but that is something which will depend on your needs and what you are trying to get out of your application. In most cases, we go for after the data is committed to the database and then the data is written into the cache. So it's critical to always test your application under load to see how your caches are performing, and make sure any sensitive information that you're storing in the cache is always encrypted, because there's a high chance that somebody might connect to the cache directly and get all the information. We are using Redis. We used to use Memcache first, but then we moved to Redis. So always be on the lookout for any caching, which caches are better, anything new that's coming into the market, and use libraries and frameworks like Spring Cache or any other. All languages have their own implementation, so you can look into that. Okay, now we answer the second question. We looked at the database, the entire breadth of how you can improve the database performance. So now we look at and try to answer, how do you distribute the load? Simple enough, use something called as a load balancer. It's a server which is specifically sitting and figuring out where do I redirect the request which is coming to me. So all the requests first come to this server, and after that it distributes that amongst your different horizontally scaled servers that you have. I think load balancer is simple enough, but there are a few things that are probably not touched upon, which is the algorithms, or how do you distribute it? Is it like any request that comes in and I just throw it to a server, or is there more to it? I'll just touch upon a few of them. Usually it's divided into static load balancing and dynamic load balancing. Which algorithm is again dependent on what you want from your application. So one is round robin, which means any request that comes in, I just throw it to a server. I don't care where. It's like, it depends on the mood. Server 1 to server 1, server 2, server 2. Next request, I can send it to server 2 as well. I don't have to wait to figure out something. I just send it. That's it. There's weighted round robin, which means you can give specific weights to particular servers. Let's say one server is having more CPU and RAM compared to other servers, so you can then give it more weightage. So it will send more requests to your server which has more CPU and RAM compared to other servers. Source IP hash, which means if a request is coming from a particular IP, just forward that request to the same server which originally did the source IP hash. Dynamic load balancing, which means it looks dynamically at certain values. Least connection is one of them. Least response time is the other. And resource based is another. So all of them look at how many connections have you built. The least connection one looks at how many connections have been made to which server, and then decide who I want to send the request to, and it will always send it to the one which has least connections. Then least response time, which is how much response time is coming from which server, and look at which one is the least, and then direct that request to that. Resource based is again based on what resources are where. So mostly load balancing algorithms are just that. Application support for horizontal scaling. Now, this is a little important. Why? Because it's important to look at your application and figure out if it is ready for being horizontally scaled. So let's say if a request comes on server 1 and you're storing something in memory, the second request for the same flow comes to server 2, but server 2 does not have access to server 1's memory, so it will not be able to fetch the data that you stored on server 1's memory, right? So you need to be able to do something called statelessness, which means any request that comes in, your application regardless should be able to respond to that and should not depend on something that you're storing in memory. If you do have to store it in memory, I'll recommend use a common cache or database from where you can fetch. So that's something which you will need to look at when you're writing your application code. Session management becomes easy, same thing, same lines. You can figure out where you want to store the data. Avoid using auto-incremented IDs. So your database has something called primary key or auto-incremented IDs. If you're using that in your application, it's recommended don't use that. Use GUID or something else. If you're using, horizontally scaled or multiple databases, it's always a good idea to use GUIDs. And use, we talked about read and write replicas. So if you have multiple servers, your application should be able to connect to each individual read replica. So that is something also you'll have to take care of. Let's look at how to scale servers. Simple enough. The manual approach is monitor performance, set up alerts, and add servers manually. So how do I monitor the performance and how do I set up alerts? So there are some of the, everything on the right is a little on the paid side. On the left is paid, on the right it is open source. These are some of the tools you can use to monitor your application performance and also set up alerts so that if you want to go in and manually deploy new servers, you can do that. But then who wants to do this manually? So there's something called auto scaling, which you can look into. Again, this brings a little bit more complexity. Any platform that you're using to deploy your servers will have some sort of auto scaling functionality. So I'll recommend just look into them. One key point you need to take care of here is set a limit of how many servers should get auto scaled to, because let's say if there's a DDoS attack, you don't want 1 million servers which got scaled and provisioned, and then now you have to pay $10 million to AWS because you didn't put a limit to it. Two things here. There's something called scale up, scale out. It's parallel to are you trying to vertically scale or are you trying to horizontally scale? Both types of auto scaling functionalities are there in various platforms. So mostly that's it. In terms of, those are the common ones which you can start looking at. You don't have to delve into something like, okay, I need to go to microservice. Looking at where the bottleneck is, looking at your application code, looking at how you can auto scale, all will reap better benefit. You'll be able to reap better benefits than moving your entire application to something like a microservice. But because we are all here, I'll still touch upon microservice. I just wanted to put this. I don't know how many of you have read this article, but basically it means, this is by a senior software engineer at Prime Videos, which said that we moved from a microservice to a monolith and it gave us better scalability options and was also cost effective. So it's always critical to have a holistic view of your application and figure out what is the best fit. It's not always, like how microservice karenge, it will give us better benefits. It adds its own complexities. I'll not be going deeper into microservices. I think there were other sessions and it will just be redundant and also lack of time. But these two memes should, give a little bit of an idea on terms of what's left. So jokes apart, microservice does help in certain cases. It helps with scalability. You can scale individual servers rather than your entire monolithic server. It gives you flexibility in using technology. You can have one technology for one service and another technology for another service. It gives you resilience. That means some of the services can be up while some of them are failing, and then you can look at that. Deployment speed and team autonomy, which means you can have multiple teams working on multiple services and they're doing their own thing. So microservice helps with that, but then it brings in its own complexity in terms of how does service to service communication happens. Then using message queues, and then there's an overhead of other things that you need to take care of. So yeah, it's like a bottomless pit. You get into scalability, you figure out there's always something new which is happening. And I just wanted to summarize quickly. Scalability is multifaceted, and look at from database to application code to everything first before jumping with a new shiny thing like microservice. Look at your queries because they'll reap, you'll be able to reap better benefits. It will be cost effective. It's not always the hardware. It's sometimes your shitty code that you write. So it's always important to look at your code also. Use the right tools. And remember, adding anything new to your infrastructure will always add complexity. And it's always a continuous evolution. So for all of you who like signing new stuff, I'll just leave you with one keyword, and that's about it. That brings me to the end of my session. I didn't, go deeper into. I just give you a holistic approach in terms of what you should look at. Might not be too fancy, but then most of the stuff when you're related to scalability is not that fancy, and that's what our experience has been. So thank you guys. Thank you for being a lovely audience. And I know this is the last session. Thank you for coming to IdentityShield. If there are any questions related to this, I think there's a mic there. You can ask me or just shout. And please do give feedback on the session. Yeah, thank you, everybody. Any questions? Yeah, you can use that mic. Yes.
So deadlock, this can be what the deadlock is because they use universe.
Right.
Like here, the is active.
If it's happening, a deadlock is happening. So what does a deadlock mean? Deadlock is when your database, in context of database, your database is performing an operation, and at the same time, the same request for the same functionality comes from another user or request, and then your server is waiting for an operation to finish before the next one. Usually that does not happen in database, in my opinion. Depending on it depends on your application, basically. What kind of queries is it making, or are you performing some heavy operation or database related operation? As long as you're reading and writing to a database, I have not encountered a case personally where there'll be a deadlock. But let's say you are running partitioning or something else, which might cause some deadlock. So you will have to handle it on your end in terms of how you're performing partitioning or sharding or anything of those things. So that is something which you'll have to handle. If it's happening application-wise, do it application side. You'll have to look at your application side. And if it's something you're doing manually, then you have to take care of that in the process. Yes, you can come forth and ask your question so that everybody can hear it out.
Hi. So as there are functional regressions, there can be scalability regressions as well. I'd like to hear a few, lines in terms of your experience about how you could build processes or experiences about catching them earlier in the development life cycle.
Regression, functional regression,
Scalability regressions.
scalability regression. Could you give an example if you don't mind?
So essentially, as developers are building features or fixing issues, right, you tend to introduce certain scalability issues, which was something was much more scalable earlier, and then certain operations were introduced that caused the scalability to go down. So are there, have you had any experiences there and any processes that helped avoid them earlier?
Well, the only regressions that we have encountered is functional regressions in terms of if there was some functionality in the application that got removed in the next release. Usually unit testing or some sort of integration testing helps with that. From scalability regression, I have not encountered it personally. If there is something which is happening, it's probably on the DevOps side. And usually developers don't cause scalability regressions. It's probably something which happened on the DevOps side, if I'm getting that right. Right.
Okay.
So, but yes, we have encountered functional regressions and just have proper unit test cases or integration tests, automated tests to avoid, functional regressions that might show up.
All right. Thank you.
Yes.
Like to know which server is up, like a miniOrange IDP uses health check mechanism or a heartbeat mechanism.
Right.
And like which is more costly, like which one to implement, and like do we go for both or just one?
Which two are you talking about? Health check and?
Check and the heartbeat mechanism.
Heartbeat mechanism. So I think, how does health check happen?
Like the load balancer will do it from its own end, and the heartbeat, the services will do.
Right. So one thing it does, it looks at your I know two ways. One is a heartbeat mechanism that it frequently polls the server and sees if it is up. Another one is it looks at your response time. If there's no response coming from the server, then it tends to it will detect that, okay, there's something wrong in this. There's no response coming from it from, let's say, past 1 minute. On the IDP side, we are using a heartbeat mechanism. We have a check server HTML endpoint where it just pings and figures out if the server is up. Usually it's not that heavy, so you can choose either or. Because it does not use any resources, but it depends on what that endpoint is doing on your application side. If it's a simple HTML page, it's fine in my opinion. Or if it's doing some other processing in the background, then avoid that and go for another approach, which is look at the response times and then figure out if the load balancer should block request to that server. Does that answer your question?
Yes, like which is the default one? Like we can.
So by default in AWS, it depends platform to platform, but I think usually everybody goes with the heartbeat one. In AWS, I know that you put in your load balancer, you just give a endpoint which it constantly pings to figure out if the servers are up or not. Any other questions? Cool. Thank you, everybody. If there are any other questions, you can just get a hold of me after this session. And I think it's lunch now, so we can all go for lunch. And again, thank you for coming to IdentityShield. I think this is the last session of the day. And yeah, thank you.